Slack's outage on January 4th, 2021. A DevOps Postmortem. It's the first Monday of January, and for millions of people across the globe, it's the first day back at their desks after the holiday break. The caffeine hasn't even kicked in yet, but the digital workspace is already screaming. By 7 a.m. Pacific Standard Time on January 4th, 2021, the silence of the holidays was replaced by a wall of noise. Slack wasn't just lagging. It was effectively dark. Users couldn't send messages, connect to channels, or even scroll through history. The platform, the literal nervous system for modern teams, was paralyzed. While the sheer scale of the failure was massive, the engineers on the front lines were flying blind, staring at a dashboard that wasn't giving them the answers they needed. Something fundamental in the infrastructure had buckled under the weight of the morning surge, and as the minutes ticked by, it became clear that this wasn't just a minor glitch. It was a total systemic collapse. Imagine it's the first Monday back after a long holiday. Everyone is logging in, caffeine is kicking in, and suddenly the system just stops. On January 4th, 2021, Slack hit a wall because their infrastructure couldn't handle the massive surge of traffic from people returning to work. It wasn't just a minor glitch. It was a full-scale collapse where users couldn't send messages or even see channel history. The real culprit was an overloaded AWS transit gateway that failed to scale quickly enough, causing massive packet loss and high latency. To make matters worse, their provisioning service started choking on API rate limits and exhausted file handles, making it nearly impossible to spin up new servers to handle the load. It wasn't until 10:40 a.m. Pacific Standard Time that AWS engineers manually boosted the transit gateway capacity, finally clearing the congestion. This was a brutal lesson in how predictable calendar spikes can turn into catastrophic failures when your underlying infrastructure isn't prepared for the crowd. It was January 4th, 2021, the first Monday of the year and a day that usually signals a massive shift in momentum. After the holiday lull, thousands of teams across the globe were logging back and simultaneously to kick off their work week. For Slack, this meant a predictable but massive surge in traffic as people flooded the platform to sync up on projects. On paper, the infrastructure was designed to handle growth, and for most of the year, it did just that. Everything seemed stable until the sheer volume of the back-to-work rush hit the network layer. The system wasn't just dealing with a few extra users. It was facing a tidal wave of concurrent connections. It was a perfect storm of timing and scale, where a standard calendar spike collided with the limits of their underlying architecture, setting the stage for a total collapse of connectivity. The first signs of trouble didn't hit the public until the morning of January 4th, but for the infrastructure team, the alarms started ringing early. Around 6 a.m. Pacific Standard Time, the internal monitoring systems began flagging a spike in service error rates and general abnormalities. By 7 a.m. Pacific Standard Time, the situation exploded into a full-blown crisis. Users across the globe were suddenly hitting walls, unable to send messages or even load basic channel history. It was the first day back after the holidays, and a massive surge in traffic slammed into an overloaded AWS transit gateway that just couldn't scale fast enough. The resulting packet loss and latency saturated the web tier almost instantly. What made it a nightmare for the engineers on duty was the silent nature of the failure. Their own dashboarding and alerting services went down, forcing them to hunt through the wreckage using manual methods while the system struggled under the weight of its own failed provisioning attempts. It started with the holiday hangover, the predictable surge of millions of users logging back on January 4th. But instead of a smooth ramp-up, the system hit a brick wall. The core issue was an overloaded AWS transit gateway that simply couldn't scale fast enough to handle the sudden spike in traffic. This created a domino effect. Massive packet loss and spiking latency began choking the web tier. As things spiraled, the provisioning service started to buckle under the weight, running out of open file handles and slamming into API rate limits from their cloud provider. It was a perfect storm of saturation. The system couldn't even spin up new servers to help because the underlying network was already suffocating. By the time engineers were fighting through a dashboard that wasn't even reporting correctly, the infrastructure was drowning in its own demand, and the cascade had turned a busy Monday into a total blackout. The disaster didn't just happen because of a random glitch. It was a perfect storm of infrastructure limits meeting a predictable human behavior. On the morning of January 4th, 2021, the system was hammered by a massive surge in traffic as users flooded back into work after the holidays. The primary culprit was an AWS transit gateway that simply couldn't scale fast enough to handle the load, leading to severe packet loss and high latency that choked the web tier. To make matters worse, the provisioning service hit a wall of its own, running out of open file handles and hitting API rate limits from the cloud provider. This combination meant that while the network was saturated, the system also struggled to spin up new servers to handle the load. It wasn't until 10:40 a.m. Pacific Standard Time that AWS engineers manually increased the transit gateway capacity, finally clearing the bottleneck and restoring normal service for everyone. Imagine the scene. It's January 4th, 2021. The holiday hangover hasn't even faded yet, and thousands of teams across the globe are logging on for their first official day back at work. Instead of a smooth transition, they hit a brick wall. The blast radius was massive. Users were completely cut off from the platform, unable to connect, send messages, or even scroll through their own channel history. This wasn't just a minor glitch in the web tier. It crippled both desktop clients and web interfaces for a huge chunk of the global user base. From the initial signs at 6 a.m. Pacific Standard Time until the final fix at 10:40 a.m. Pacific Standard Time, the system was buckling under a surge it couldn't handle. By the time the network finally stabilized, the sheer scale of the frustration was clear. It wasn't just a technical failure. It was a total communication blackout during a critical peak period. The alarm started screaming early on the morning of January 4th, around 6 a.m. Pacific Standard Time. It was that brutal post-holiday rush where everyone logged back in at once, and the infrastructure team immediately saw service error rates begin to climb. By 7 a.m. Pacific Standard Time, the situation turned into a full-blown crisis. The outage went widespread, and users were hitting walls trying to send messages or even see their own history. The engineers were flying blind, too, because their own dashboarding and alerting services had collapsed under the load, forcing them into manual troubleshooting. They managed to get the provisioning service back online by 8:15 a.m. Pacific Standard Time to stabilize the web tier, but the real beast was hidden deeper in the stack. It wasn't until 10:40 a.m. Pacific Standard Time that AWS engineers finally stepped in to manually increase the transit gateway capacity. Only then did the packet loss stop, the latency drop, and the system finally breathe again. The fix wasn't a simple flick of a switch. It was a grueling manual grind against a saturated network. By 8:15 a.m. Pacific Standard Time, the team managed to restore the provisioning service just to get the web tier serving again, but the real bottleneck lived deeper in the infrastructure. The culprit was an overloaded AWS transit gateway that simply couldn't breathe under the post-holiday surge. It took until 10:40 a.m. Pacific Standard Time for AWS engineers to manually crank up the TGW capacity, finally flushing out the packet loss and stabilizing the latency. To keep things from collapsing during the heat of the moment, Slack also disabled downscaling on their web tier to preserve what little capacity they had left. Moving forward, they overhauled their capacity models to account for predictable calendar spikes and implemented stricter warm-up strategies for caches and connection pools. They learned the hard way that when the surge hits, you need a system that fails gracefully instead of buckling under the weight. The true scars from this battle aren't just the lines of code, but the realization of how fragile our dependencies can be when the world suddenly wakes up. We learned that capacity models must account for predictable calendar spikes. Those post-holiday returns aren't just traffic. They are massive surges that can trigger unpredictable behaviors when multiple systems try to warm up simultaneously. Furthermore, we saw how a lack of resilient monitoring, specifically when the dashboarding and alerting services went dark, forces engineers into a manual, blind hunt for the source of the fire. We also realized that systems must fail gracefully. If you don't have clear degraded modes or proper warm-up strategies for caches and connection pools, an overload becomes a total collapse. Finally, we saw how the deadly dance between auto-scaling logic and underlying network issues can backfire, where instances are marked unhealthy and downscaled just as they are needed most, compounding the failure instead of solving it.